Good morning, my dear students. So again, I'm going to solve in this class again continuation of the forced problem. Okay, that is a forced vibration problem. Okay, so third question is given like this. So again, same a 54 Newton weight is suspended by a spring with a stiffness of 100. That is a 1100 Newton per meter. So it is forced to vibrate by a harmonic force of 5 Newton. So it is going to vibrate within a force that is in force that is called as a harmonic force of 5 Newton. Assuming the viscous damping in a particular given weighted suspended weight machine is what the damping is. The viscous damping is 77 Newton second per meter. Find the following values. Okay, that is a resonant frequency, amplitude at resonance, and phase angle of a resonance, and a damped natural frequency. Again, the frequency at which the maximum amplitude of a vibration occur, and the speed at which the maximum amplitude of a vibration would occur, and the seventh one is the peak amplitude or the maximum amplitude, and eighth one is a phase angle corresponding to the peak amplitude within or a maximum amplitude. Okay, so I taken this problem from the university only. If you solve the 8 factors, that is the 8 quantity what they are to calculate, what they are asking. Okay, so this almost 4 to 5 problems cover in this problem only. Okay, so if you remember all these formulas. Okay, here I will read out the question again. A 54 weight is suspended by a spring within stiffness of 11, that is 1100, that is a 1100 Newton per meter. Okay, so that is a spring mass damper. Okay, so it is forced to vibrate with a harmonic force of 5 Newton, that is an external force is applied, that is called as a harmonic force, I already told. Okay, so assuming the viscous damping in the particular system is 77 Newton second per meter, find the following key factor. Okay, so before solving the problem, I told you always to recall your formulas what I given in the list of formulas and notation of the symbol. Okay, at resonance I told you omega is equal to omega n. Okay, frequency, amplitude, peak amplitude, maximum amplitude, both are same. So I told you. Okay, so and also phase angle. Okay, so here the given data is given m is equal to 54 Newton, that is mass is given. So note down the given data first, that is k is equal to 1100 Newton second per meter. Force, that is a harmonic force, is 5 Newton, and the damping 77.77 Newton second per meter. Okay, so let me solve one by one with the list of formulas. Okay, so open your notes, that is the model 4 notes I given in the list of formulas also. Okay, frequency is equal to what? So omega is equal to omega n, so that is square root of k by n. So we have the form, that is values of stiffness and also mass. Just to substitute within gravitational force, that is 100 the force into gravitational force, that is g is equal to 9.81. Just to substitute, you are going to get omega is equal to 14.14 radian per second. Okay, second is amplitude of the resonance. Okay, so at resonance omega by omega n is equal to 1. Therefore we have the formula what? X is equal to capital X is equal to f naught by k divided by 2 zeta. Okay, so where how to calculate zeta? Again we have the to calculate zeta is equal to what? C by 2m omega n. So this is equal to 77. C is given, that is damping, whole divided by 2 into mass, that is 54 by 9.81. So 14 into 14. Okay, so if you substitute all the values, you are going to get the damping factor zeta is equal to 0.495. Okay, now you substitute in the, that is a this at resonance formula, x is equal to 5 by 1100 divided by 2 into 0.459. Okay, if you substitute, you are going to get what? Here the amplitude at resonance is equal to x is equal to what? 4.59 into 10 to the power minus 3 meter. Okay, so third one is the phase angle at resonance is equal to what? I told you at resonance omega by that is omega is equal to omega n. So again the formula what? Phase angle, already we derived this equation, tan phi is equal to 2 zeta omega by omega n whole divided by 1 minus omega by omega n whole square. This is the formula. Okay, so where, so the bottom is that is going to consider 0, that is tan phi is equal to 2 zeta by 0. So tan phi is equal to infinity, so tan theta tan infinity is equal to what? 90 degree. Okay, so because here we are going to consider 0, but because at that particular system we are not going to use any working system, not it, the system will not work. So assume going to consider, that is assume as 0. Okay, so last fourth one is the damped natural frequency, that is the undamped natural frequency omega d is equal to omega n square root of 1 minus zeta square. So again we have the formulas omega n and zeta. Just to substitute, omega d is equal to 12.286 radian per second. Okay, again the fifth one is the frequency at which the maximum amplitude occur. Okay, that is the peak, at the peak level. So omega peak is equal to, we have the formula omega n is equal to square root of 1 minus 2 zeta square. Again you substitute, you are going to get the frequency at the peak is equal to 10.1 radian per second. Okay, At the sixth one is the speed at which the maximum amplitude of a vibration would occur is equal to what? The peak amplitude is equal to pi the maximum speed divided by 60. We have the formula this. Okay, just to substitute the formula, that is speed is given 60, so you are going to get the maximum speed at which the amplitude of the vibration would occur is equal to what? 96.45 rpm. Okay, again the seventh one is the maximum amplitude or a peak amplitude. Again we have derived this equation in the previous class. It is x of p, that is the peak amplitude is equal to x resistance 0 whole square root of 1 minus zeta square, or this is equal to f naught by k whole divided by 2 zeta square root of 1 minus zeta square. Okay, so we have all the formulas, that is all the form symbol, that is a meaning values. So just to substitute here, x of p is equal to 0.057 meter. Okay, so eighth one, that is the last one, is the phase angle corresponding to the peak amplitude is equal to what? Phi is equal to tan inverse of tan inverse 2 zeta omega p by omega n and whole divided by 1 minus omega p by omega n. Okay, so again here also we have all the values. Just to substitute, you are going to get the phase angle corresponding to the peak amplitude is equal to 55.25. Okay, so this is an angle we are going to making in the particular system with respect to the peak amplitude. Okay, so like this you are going to solve the problems on this forced vibration. Okay, so just to nothing but just to remember the list of formula, that's it. Okay, so model 4, that is a what number 4 formula is again I am going to solve here. So here also read the question. If you are not understanding question, means read twice thrice. Okay, note down the question. Okay, so that is a mass of 100 kg been mounted on a spring mass, that is spring mass system having a spring stiffness of 19,600 newton per meter and the damping coefficient of 100 newton second per meter. The mass acted upon which the harmonic force 39 newton at the undamped natural frequency of the system. Okay, so determine or calculate the what? The amplitude of vibration of a mass and the phase difference between the force and the displacement and the force transmissibility ratio. Okay, these are the three factor they are asking to. Okay, so they given spring mass damper system. So in that particular system the given data is given like this. Mass is given 100 kg, k is equal to 1960 and the damping 100 newton second per meter and f naught, that is force exerted on that, is 39 newton. Okay, so convert into the standard, that is a what SI units. Okay, so first to solve the given question we need what? Omega n. Okay, omega n is equal to what? Square root of k by n. So just to substitute, you are going to get the omega n is equal to 14 radian per second. Okay, again cc is equal to, we have the formula this 2m omega n. Again you substitute, you are going to get the critical damping coefficient is equal to 2800 newton second per meter. Okay, so again the damping factor we have the formula c by cc. So substitute, you are going to get the damping is equal to 0.0357. Okay, so I told you if the damping value comes less than 1 means it is called as a underdamped system. Okay, so first they are asking now the at the undamped natural frequency, at that particular frequency omega is equal to omega n. So hence the amplitude of the vibration is taken as what? F naught by k, that is force exerted, divided by square root of 1 minus omega by omega n whole square to the whole square plus 2 zeta omega by omega n whole square. Okay, so this formula we already derived, and this is also very important for the point of examination. Derive this undamped natural frequency, that is the maximum amplitude. Okay, so you have to remember that formula. So again we have the all the data. Just to substitute, we are going to get the maximum amplitude is equal to 0.0278 meter. Okay, second one is they asking what the phase difference at omega is equal to omega n, that is the angle. So we have the formula what? Tan phi is equal to 2 zeta omega by omega n whole divided by 1 minus omega by omega n whole square. So again this is equal to what? The 0. So again we are going to get tan phi is equal to infinity. So again phi is equal to pi by 2, because that 2 to going to get cancelled. So you are going to get the phase angle is equal to 90 degree. Okay, so C1 is the force transmittability ratio. Okay, again we have derived this equation. Force transmittability ratio is equal to what? Square root of 1 plus 2 zeta omega by omega n whole square divided by square root of 1 minus omega by omega n whole square to the whole square plus 2 zeta omega by omega n whole square. Okay, so if you substitute all the values, you are going to get what? Transmittability ratio is equal to 14.04. We have all the data. So just to substitute, take the calculator, cool, and just to substitute, you are going to do the calculation, you are going to get the accurate. Okay, transmittability ratio almost all in the all the problems it will 14 to 16 maximum. Okay, so it has no unit. Okay, that is 14.04. okay, like this you are going to solve the problems on forced vibration. So just you have to, I told number of times, you have to remember the formulas in the coming, that is the model 4 and model 5, that is vibration chapter, that is model 4 and model 5. Okay, so it is very simple as compared to that is the model 1 2 3. Okay, so this is just you have to analyze and remember the list symbols and apply, you are going to get this. Okay, So I hope you understand this type of problems. Okay, so what you mean by forced vibration? Okay, so I told forced vibration means you are going to put in this problem some external force to generate the particular system, that is to vibrate the particular given system, that is called as forced vibration, that you need to study in this chapter. Okay, so based on only we are going to solve the problems. Okay, forced vibration, harmonic vibration, forced transmitted vibration, impressed forced vibration, all those meaning we have to remember. Okay, so at resonance frequency is equal to omega is equal to omega, and like that the also some notes also are given at particular stage of, okay, that also you have to remember. Okay, like this you are going to solve the problems on forced vibration. I hope you understand this up to fourth problem, 1 2 3 4. Okay, so problems on forced vibration. Okay, so I hope you understand this. Thank you.